I'm at Asnuntuck Community College, and we're going to get a tour of this college pretty soon. They're having a brief car show up front as well. Let's hope a lot more people show up because the sun just finally came out. Nice college though. Anyway.
We call it the Juggernaut.
You know what? I think I saw you once before with Juggernaut. Were you here a couple years ago at the show?
Probably, yeah.
This is the Juggernaut. Look at these tires, you guys.
These are actually liquid fluid hydraulic suspension, so I don't have to go in there and pump air up. There's already liquid inside of it.
Wow, that's amazing.
Thank you.
Yeah, this is your means of transportation?
Yeah, for now.
Okay.
I hope to one day get it nice and, electrified so I can do like 30.
Electrify would be really cool. You got to be in good shape though to be driving this all the time.
Oh yeah, I've already lost 20 pounds a week.
I can imagine.
It's like, trying to drive, with most bicycles, it's like trying to drive like a little gazelle. You can sort of like throw it back and forth. This is like driving a rhino on steroids.
A rhino on steroids, okay.
He's like, I just want to go straight. We gotta turn.
Wow, and so these are your lights and everything?
Yeah. These lights are really bright. I give Audi drivers a run for their money with these.
Okay, and you even have a phone holder on it.
Once I electrify it, I'll be able to charge the phone as well.
Oh, that would be wicked cool, yeah. That's neat. Oh, very good. Nice meeting you.
Nice meeting you too.
Yeah, you too. This van has been around. Look at all the stickers.
Thanks for coming. Don't forget, we've got trays available in our manufacturing every 30 minutes.
This is a 69 VW bus, and he's owned it for 46 years. He traveled all over with it. Check out all the different stickers that he put on his VW van.
Oh, did you? Yeah. Nice.
This is a nice Studebaker. This is 1948 Studebaker. I love this car. I just saw it recently at the Manchester Main Street show as well. Had to check it out a little bit more. It is a beauty, all right. Here's a very cool 62 Nova. It's been in the family for several generations. Well, we're finally filling up with some cars. Oh, this is a beautiful Blazer too. Check it out.
Yeah, these are limited, but they're cool. Definitely fun to drive. It sure does. Nice. Couple cool guys on these trucks. Like the license plate Slowpoke.
Gotta love the cowboy hat.
Miss Galaxy.
And free pizza.
Wow,
Being
free-
delivered, should be here in about 15 minutes. By 6 o'clock. So, by the time you get done your show, you'll be ready to have something to eat. There's pizzas and free pizza going to be coming, being served at 6 o'clock.
This is inside. Oh yes, okay, thank you. This is inside of Asnuntuck Community College. Let's go check it out. It's so cool in here.
They're giving tours of the college today.
We're going to be seeing the welding department, CNC department, and other areas of the school.
You guys enjoy your tour. Thank you all for coming.
Hi there.
Thank you.
I made it.
We're headed towards welding and towards mechatronics.
Okay.
So really it's, with manufacturing like that, you're a long time, right?
This building was an old junior high. And look and see what we're getting into here.
Gary's desk is right behind you over there. That's where he sits in there. This is our lab area here to deal with the technologies of automation. This area, all the different Lego pieces of automation are broken apart into their individual components. So I like to say that automation really is pretty simply, I gotta take some energy, I gotta move it somewhere to do some work. So the energy of automation, electricity, hydraulics, and pneumatics. So our students in just 30 weeks have to learn everything, right? So we have a circuit theory, an electrical theory piece that we talk about, right? We do hydraulics and pneumatics and that kind of thing, so that they understand the foundational stuff of how that energy works. And then we would come to a trainer like this. This is a motor control trainer. All of these things here are the way that machines were controlled in the past. Relay logic, electrical switches, things turning on and off to control when a motor turns on, what direction it goes, how fast does it go, how long does it stay on. Those kinds of things can all be done with a board here. And we have to explain to the students how all of that works, because we have to control that energy, right? So we learn about energy, we learn about how energy is controlled. We have to learn about the output devices of that energy, the motors, the actuators, those kinds of things. And then for automation, we have to learn about how does the system learn information about what's going on in the process right now. We have to learn about sensors and input devices and all of those kinds of things. It's a huge buffet of a lot of different Lego pieces that I'm throwing at people, right? A component like this, it's a motor starter. It has a switch on it, it turns the motor on. I'm gonna see one of these in just about 50% of all of the pieces of equipment. It's gonna look a little different. It's gonna have the same kind of stuff to it, but if I can teach you how to recognize that and you know immediately what it is, suddenly you have some logic of what the device is doing when it has that piece in it, right? Every machine's gonna have one of those, a transformer. It's used for control, things like that. I have to teach you what that is so that you know what its purpose is. Because we're making technicians that are maintaining these kinds of things, right? So they'll be able to understand what that is so that they can use it in their diagnostic process to figure out what's wrong with my machine.
How many kids are in your class? How long is your class and how many kids?
So we have two 15-week semesters. It starts in the fall, it goes to mid-December or so. We break until mid-January or so. We go another 15 weeks. So in 30 weeks in this program, you end up with a certificate, robotics and mechatronics technician. That's the core credits that you need for an associate's degree in robotics, mechatronics, and technician that you can get here. You take your associate's degree and you go to Central and you can turn it into a bachelor's in electrical. There are juniors and seniors that come through here and end up getting 4 classes worth of credit in their high school dual enrolled, and then when they come here, they're a third of the way through the certificate program already.
That's great.
Right? So even before they're done with high school, we have them in here. Then fresh out of high school, but we also get returning workforce. We get people that, one of our better students was a massage therapist who was like, I'm just done with this, and he came into here, but he had that science medical background. It's amazing how similar our automated system called the body is to the way a lot of this stuff works, and keeps.
Here's a robotic arm. Look at the different components the students have to learn.
We sort of skipped past the welding department. But the welders are all AWS certified so that they can give welding credentials. You need a welding license to be a welder and put things together safely. So we can provide those credentials along with our certificate program. They've got water jet cutters and plasma cutters and benders and breakers and all that kind of thing that they play with there. Right now we're in additive and subtractive manufacturing. So additive is 3D printing and subtractive is machining, taking material away from parts with mills and lathes and CNC devices. So there's some of the examples of some of the things that they play with there. And then my program here is at the end, and the little electrical widgets that we play with and things. That's my son's Halloween mask. It opens and closes.
Oh, that's going to be wicked cool. Wow, that's amazing.
Fun to build that whole thing. But it includes a lot of the different
neat.
things. It's 3D printed and all that kind of stuff.
Now, how do they keep you guys current? Do they keep sending you?
Oh yeah, we're constantly getting training. I'm actually getting some more OSHA training next week.
That's wonderful.
Yeah.
Good.
Yeah.
This is a cool place.
So in this building are all the machines that my students get to fix, right? When something in here breaks, they call us up and we come running over and do real world practice on it. Right?
That's awesome.
They also have a program where they how to use these things, right? And that's the machining program. This is a CNC mill. I'm sure that you could give me a class on it more than I possibly could.
What was it was keeping that vacuum.
Yeah.
There's a lot keeping machines active in the aerospace industry. The tolerances are half of 1/10,000th of it. Now, take that into perspective. A normal person's hair is about 10,000th of an inch thick. To get to 1,000th of that, you divide that by 10. 1 by 10. That's one thickness here. Now you divide that again by 10.
Imagine.
And that's some of the accuracy of these machines.
You heat
That
that
is so
part
ac-
up by 20 degrees and it grows by that
It
much,
does,
just
more
by
than
expansion.
Temperature is
Yeah.
huge, even
Yeah.
just in the base of the machine. If the machine runs, it warms up. And everything has to compensate that. It's electronic compensation, mechanical compensation.
Something.
Equipment in here. Easy.
Yeah.
Right. Some of the equipment on its own, like that big Mazak back there, is 750, close to $1 million on its own. But we have CNC mills, CNC lathe. This is a Swiss lathe, which is really a cool, fancy watchmaking kind of device. Make really tiny,
Doesn't look
small
like much.
parts, and yeah, it doesn't look
Yeah.
like much. But man, this thing can do cool stuff.
Amazing.
So that whole entire part, I believe, was made on the Swiss lathe all by itself, right? So when you think about a lathe, the lathe is spinning the material, right? And we run a tool past the spinning material. How did they make that? Well, yeah, this has another axis on it that I can spin something else past. So like in a traditional lathe, it's the part that's spinning. But here, we can do both. We can spin the part or we can spin the tool, right? We hold to fix the thing in place.
Okay.
A Swiss lathe is cool because the collet allows the part to slide in and out. So I can move the part out a little bit, do a thing, suck it back in again, which it's all automatic. We can press the go button on this and it'll make 100,000 of these things.
Imagine that.
You know,
That's crazy.
That whole big bar feeder through the side of it, that is just holding a big long rod of this.
Wow.
And I
Wow.
can just keep firing it out.
That's something else.
These were all different CNC machines. The thing that I found was remarkable, the place was very clean, very tidy. Here's some parts that were produced by these machines. These were the bridge ports.
They start out the program with a little package where all they do is they make a T-slot cleaner, right? You do it with a hacksaw and a file, and you mark it out with Dicom, scribing like that, and figure it out with the highway that they're working. And then from here, you go to the CNC. Right? We have lots of different technologies to do that. These are all the lathes.
These are the lathes. So much for them to learn, huh?
Prepped for this open house.
Yeah, I think so.
How come it's so clean here?
In the 50s, the Japanese started a business model called Kaizen, where they were trying to figure out how do we implement processes that make things more efficient, that save us money, that save people's lives, that do all these kinds of things, right? It's lean manufacturing, they call it, right? And one of the big principles of lean manufacturing is keeping things tight, right? Keeping things organized. Keeping the things that I need to use for my job within arm's reach so I don't have to keep going back and forth to
In the
print.
same place.
Additive manufacturing area. So additive manufacturing is 3D printing.
That's right.
We can 3D print things out of various types of plastic, but we can also, we're buying a machine that we can 3D print things out of metal.
It's pretty cool.
We two tours crashing into each other at the moment right now, but there's some examples of the things that we printed up along the way over there. Those are all, you know, fun little models that we make. Students in here will learn how to do the CAD design for these, so they'll learn how to program a computer to be able to model something like that. They'll be able to output it. They'll be able to learn to read blueprints and things like that in here, so that they can piece apart.
It's interesting.
Describe them for an engineer.
It's some of the things that they made. It's amazing, huh? Yeah.
So learn that disconnect between when you see something on the
Guitar.
These were all done on a 3D printer.
Metal things
they
too.
get some of that practice. So it's laser etched. We didn't talk about the surface parameters back there, but basically you have a special abrasive wheel that makes the finish on the. This was a scan that was created of someone that had needed some back surgery or back repair.
I just had it
They gave us the scan, we 3D printed it so the doctor could see what he was going to be doing
That's amazing.
before he went in there and did it, so he could get some practice and like see exactly what was going on in his hand.
It's
Amazing.
amazing, is right.
And there's
Yeah.
no way you could machine this piece.
It's unbelievable.
Right? There's holes in places where you can't get a drill or an end mill or anything like that. That's kind of the cool aspect of 3D printing. There's blue wheels, there's the clear body. This is all one print,
Amazing.
right?
It's pretty
And
cool.
so that's not something that you could ever machine, right?
must love
This is so, I know, this is
Yeah.
amazing.
It's all about learning through play for me.
Yeah.
But
That's fun.
We try to come up with these projects, some way, a place to get to, and we're going to teach you how to get there.
Yeah, it's really
And then
awesome.
people have a goal in mind, right? They
You'll
know
never need to
why
make one of
they're
those,
learning.
but
They'll
you
never need
know
to make
how to
one of
make
these.
something.
Might be one of our deans.
Oh, sorry. Wow, that's cool.
Is that Tim?
I'm not sure. So many people got scanned.
I
So many people
think
got
this one's
scanned.
Tim. So this is one of our dean of students.
Is this class?
So this is dimensioning and tolerance. So this is where you learn how to measure those really small distances or really large distances accurately and precisely. This is actually a jet engine part that came out of an actual jet engine from Pratt & Whitney. It went through their inspection process and they found a defect with it, so they marked it as do not use ever again, but this actually saw some time inside a jet engine at some point, so we have it in here so that we can teach our students, okay, well, let's do some of the measurements on here and find out why Pratt & Whitney rejected this thing. What's wrong with it, right? And they'll have to find, oh, well, this hole is elongated by, 10,000th of an inch, right? And
Another thing is too, you look at how many holes are on the top of that measuring machine.
yeah, but there's a funny name for it, and I can't think of it off the top of my head, but this is a robotic way to measure parts. So I can use that to program the part. It has that little probe on the end of it. The robot moves the probe around the part and very accurately measures, the piece to find out for.
Nice campus here.
I hope you found this interesting and educational. Now back to the car show. This is a cool 1960s Studebaker truck. Okay, this was a 68 Olds Cutlass S originally, made into a Hurst Olds. Check out these shifters. This is a great college that offers certificate courses, so check them out if you're interested. Due to the music in the background, I'll have to tell you a little bit about what he told me about this car. He purchased this in 2005 as a stock Studebaker, fire engine red. He drove it that way for about a year. And then he did over the engine transplant, the transmission transplant, and rear end and rear suspension. It also has all new interior and wiring and air conditioning. In 2007, he took a month road trip with it. He put about 10,000 miles on it. And then about 2 years ago, he put it in a body shop and had the body and paint done and interior done. Mike gives his wife credit for having her push him to get this car done. Thank you guys for showing this car. I'm proud to say it's my lucky duck pick.
That sounds really cool.
And here are some upcoming shows. Thanks for watching, everyone. Don't forget to hit that like button.